Welcome back, student, to this part where we will do only one example because this part is a little bit long. In this example, we want to find the tangent, the normal vector, and the binormal vector to this vector valued function at a specific point. So we need first of all to remember what's the formula for each of these, and then we will prepare the ingredients. So let me start first with the unit tangent. So number one, the unit tangent vector, which is given by this formula. T of t equal, we need to find the first derivative, and then we take the length of the first derivative. So that's what we need to do first. So let me just find the first derivative. This would be 2t. And then we have 2t cubed, 2t squared. And then 1. This is the first derivative. And now we need to substitute it here. So t of t equal the first derivative over the magnitude of the first derivative. So the first derivative is 2t, comma, 2t squared, comma, 1 over the square root of each component square. So it would be 4t squared plus 4t power 4 plus 1. Which is, if we do it in a component-wise, and we will need it to be in a component-wise later, it will be 2t over the square root of 4t squared, 4t4 plus 1, comma, 2t squared over square root of 4t squared, 4t cubed plus 1, comma, 1 over the square root. 4t squared, 4t cubed plus 1. That's exactly what we will get. Of course, what we need now is to find how much is the unit tangent vector at exactly this point. Now, if we just look at the vector valued function and my point, I can notice that the z coordinate, the third one, is exactly t. So I know that I need to substitute t equal to 1. So just let me write it down here. T equal to z equal to 1. Now we need to find the unit tangent at 1. So this would be the final answer here. So if we substitute 1, we will get the following. If we substitute 1 in the denominator, this will be 4 plus 4 plus 1 over, it will be 9. So we take the square root of 9. So 9 would be in the denominator for each one of these. If we substitute 1 in the top, this would be 2, 2, 1. Oh, I'm sorry, it's square root of 9. So this would be 3, 3, 3. So 2 over 3, 2 over 3, and 1 over 3. And that's the unit tangent vector. Number 2, we need to find the normal vector. So let's go and find the normal vector. So just let me stop here to the normal vector, which will be given by the formula n of t equal, we take the derivative of the unit tangent over, of course, we normalize it, so we get a unit normal vector. So all what we need is to find the derivative of this one. And that's which will take a little bit of time to find the derivative of this one. Of course, luckily, we need only to find it at t equal to 1. So I will find the derivative, and then I will substitute. I don't need to simplify. I just need to substitute t equal 1 to get the t prime. And then once I get t prime, I need just to find the magnitude of t prime, and I will get what I need to get. So I hope you are ready. We'll do the derivative. So let me do the derivative, and I will use a different color here. So what is t prime of t. Of course, it will be the derivative of each one of these three functions. And each one of these three functions is a function of a single variable, something that we have already done that in calculus 1. So for now, let's focus on the first one. And remember, how do we find the derivative of such function in calculus 1? Of course, we will use the quotient rule. So what was the quotient rule? The quotient rule is the following. It says, first, you need to take the denominator and you square it. So we take the denominator and we square it. Remember, I will not simplify anything at this point. Keep everything as is, because I will substitute 1 in a minute. After we take the denominator square, the quotient rule says that you keep the denominator in the top. So I will keep the denominator in the top. And then you need to multiply by the derivative of the numerator. What's the derivative of 2t? It will be just 2. And then minus, keep the numerator and multiply it by the derivative for the denominator. What is the derivative of a square root? This is something we have already done it in calculus. This will be 2 square root of 40 squared, 44 plus 1. And then because of the chain rule, you need to find the derivative of whatever inside. And that will be 8t plus 16t cubed and nothing else. And that's exactly what we need to find for the first component. And that's exactly using the quotient rule. Of course, if we did it once, we just need to repeat it twice. The only difference, and that's why I keep it with different color, will be this one and this one. So if you just allow me, I'll just take this one and copy it, because it will be the same, and I'll paste it here. And now let's fix it a little bit. How do we fix it? First of all, this and this has to change. So this one will be 2t squared. And then I take the derivative, which would be 40. And do the same thing for the third one. Again, we paste. And for the third one, this here and this here, I think this is 1. And derivative of 1 will be 0. That's how we find the derivative. Of course, now we need to substitute 1 everywhere. In each one of these, we just need to substitute 1. So if we did that and we have the calculator, did everything correct, the answer will be the following. So we will get that n of t, or at least n of 1, will be t prime of 1 will be negative 2 over 9, negative 4 over 9, negative 8 over 9. Please check and confirm to me that this is what we will get. And once we have the derivative, we can now find the normal factor at 1. It is the t prime, t capital prime at 1, over the same one, but we just need to find the dou. Over, we take a big square root, and we write each component here. So negative 2 over 9, negative 4 over 9, negative 8 over 9, and the final answer will be 1 over 84, will be this one, negative 2 over square root of 16, 64, and 4. It will be 84. And then negative 4 over square root 84, and negative 8 over square root 84. And that's how we get n of 1. Final step, number 3, we need to find the binomial factor. And what is the binomial factor? It will be p of t equal t of 1 with n of 1. So this is a little bit straightforward because all what we need to do is substitute 1. Sorry, it's p of t and t, but we substitute t equal to 1. It will be just t of 1 with p of 1 with n of 1. And the cross product is something that we always can do easily here. So it would be I, j, and k. First we write t of 1. If you remember from the previous slide, it was 2 over 3, 1 over 3. And we write n of 1, which is negative 2 over square 84, negative 4 over square 84, and finally negative 8 over square 84. We need just to find the determinant of this one, and the final answer would be negative 4 over 84i minus 6 over negative 84 of j minus 4 over negative 84 of k. And that's how we find T and B. Thank you very much for watching.